Today I'm going to talk about the limit of indeterminate form 0 over 0. Okay, and I'm going to use the L'Hopital's rule to solve this type of form. And before I solve these examples, I would like to introduce the L'Hopital's rule. So when x approaches a, we have fx over gx approaches 0 over 0 or infinity over infinity. Then we can write it down as the limit x approaches a, derivative of the numerator over the derivative over denominator. Okay, so that's the rule of L'Hopital's rule. Okay, now let's take a look the first example. So the first step, we're gonna check whether this rational expression satisfy the L'Hopital's rule. Otherwise, we couldn't use L'Hopital's rule if it doesn't satisfy 0 over 0 or infinity over infinity. Okay, so let's take a look. X equals 1 plug in the numerator. That should be e to the power 1 minus e, that is 0. And of course, if I plug in the denominator, we have 0. Okay, 0 over 0. So that means we can apply the L'Hopital's rule. So let's take a look. X approaches 1, e to the power x, e prime, and then x minus 1 prime. Okay, and now we do the derivative for the numerator, and we can say we can use difference rule. Derivative for these two terms, we can do the derivative for each term. Okay, similarly, we can do the derivative for each term in denominator. Okay, and we can simplify it. Derivative of e to the power x should be itself, and the derivative of e is not exponential function, right? E is a constant, so derivative of e should be 0. Okay, so how to identify whether that is a function or a constant? You just need to check whether there has variable. Okay, if there's no variable, x or y, something like that, should be constant. And here, the derivative of x equals 1. Okay, 1 minus 0. And now we can simplify it. We have limit x approaches 1, e to the power x. Okay, and now plug in 1, we got the limit is e. So that's the answer. Okay, now let's take a look the second example. Okay, first of all, we're gonna check the condition, whether the condition satisfies the L'Hopital's rule. Okay, so when we plug in x equals 0, we're gonna find x equals 0. Here's len 1 is 0. 0 here, 0 over 0. of course, we can apply the L'Hopital's rule. Okay, now we're gonna follow L'Hopital's rule. X approaches 0, 1 over ln 1 plus x squared, derivative x to the power 4, derivative. Okay, so before I solve this guy, I would like to recall the derivative of composite function ln fx. So I write down this derivative here. Okay, ln fx, that is composite function. How to do the derivative of this guy? Should be 1 over fx, and the derivative of fx. Okay, so for this guy, we can tell what is the fx, that is 1 plus x squared. Okay, 1 plus x squared. So that means we can follow this formula, 1 over fx, 1 over fx, that is 1 plus x squared, and fx prime should be 1 plus x squared prime, and in the denominator, that is power rule, right? Power rule, 4x cubed. And again, we can following the power rule or sum rule. Here we do the derivative for these two terms. We're gonna do the derivative for each terms. Derivative of 1 is 0. Derivative of x squared gonna be 2x. Okay, and basically we can simplify like that. X approaches 0, 2x over 1 plus x squared divided by 4x cubed. Okay, so now we have rational expression in the numerator, and we have a denominator for x cubed. How to simplify this guy? What we can do is type the 1 over 4x cubed to eliminate this denominator, right? We can times 1 over 4x cubed to eliminate this denominator. Okay, now we can see, and for the 2 we can, 2 we can cancel out, because 4 can be written down as 2 times 2, right? Here's x, we can cancel out 1 is 2. Okay, now we can simplify it. That is 1 over 2x squared times 1x squared. Now here, if we plug in x0 in the denominator, we can see that that is 1 over 0, right? That is 1 over 0. So that means we couldn't use L'Hopital's rule anymore, right? So 1 over 0 should be infinity. Okay, infinity. Now let's take a look the last example. For the last example, we're gonna follow the same strategy. Plug in x0 in the numerator and denominator. Okay, numerator can easily tell, we can easily tell that is 0. For the denominator, when we plug in x equals 0, here the e to the power 0 is 1. 1 minus 1, 0, right? So we can use L'Hopital's rule. L'Hopital's rule means we do the derivative for the numerator, and then we do the derivative for the denominator. Okay, and for the numerator, we're gonna use power rule, 2x. Okay, for the denominator, we have 3 terms, so we do the derivative for the first term is itself, and the second term is 0, and the third term is derivative of x is 1. Right? We can simplify. And again, when we plug in 0 for both numerator and denominator, we have 0 over 0 again. That means we can use the L'Hopital's rule again. Ex to the power minus 1. Okay, and then we can simplify it. X approaches 0. Derivative of 2x should be 2. Right? It's because we can extract the 2 out of derivative, and the derivative of x is 1. 2 times 1 is 2. Okay, and the derivative of e to the power x is itself, and the subtract 1 is 0. Okay, we have 2 e to the over e to the power x, and when x equals 0, we plug it in. We're gonna get what? 2 over 1. E to the power 0 is 1, right? So it's 2. That's the answer.